Hey folks, in this video, we're gonna solve trig equations algebraically, and we're gonna do solutions that are not on the unit circle, and we're gonna learn how to do these with a calculator. And so if we start with this first example, it says cosine of theta equals 1/5. And in our previous video, we discussed how if cosine of theta equals 1/5, that means that the x-coordinate is 1/5. Cosine of theta is really x over r, but when we think about everything in terms of our unit circle, our r is 1. So we're really just looking for where x is 1/5. For what angle of rotation is the x-coordinate of these points 1/5? And if we look, we see that we've got a whole bunch of x-coordinates, especially over here where cosine is positive, over here in quadrants 1 and 4, but there's no 1/5 there. So we can't just look and identify the solution from our unit circle. So what we're going to do instead is we're going to use the inverse function on our calculator, and it's going to spit out theta at us. Now, before we type that in, let's think about what's reasonable here. As I already mentioned, cosine is positive. That means our solution is going to be somewhere where the x-coordinate is positive. I'm going to be looking in this first quadrant and this fourth quadrant because that's everywhere that x-coordinate is positive. But then also, if cosine is 1/5, that means that x-coordinate is 1/5. That means if here's 1/2, that means we move to the right a half of a unit at that point. To move to the right 1/5 of a unit is going to be up here somewhere. We're looking for some number between 60 and 90 degrees. So if I punch that into my calculator, cosine inverse of 1/5, the calculator should spit out 78.5 degrees, okay? So if I wanted to draw this on my other little unit circle here, it would look something like that. We'd have 78.5 degrees, and that's our solution. But we got to be careful. As we know, many of these problems will have multiple solutions. There's more than one location on the unit circle where the x-coordinate is 1/5. Some point up here would have an x-coordinate 1/5, but some point down here, even though it would have a negative y value, its x-coordinate would be 1/5. So what we have to do is we have to come back over here, and I'm just using this to visualize the whole thing, but we're gonna have something similar down here. And it's gonna have that same reference angle of 78.5. And so if we're wondering, how do I find this angle? I'm looking for the angle that goes all the way around to right there. And hopefully you're saying, oh, I know what we do. We're just gonna subtract that from 360. If I do 360 minus 78.5, that's going to give us our other solution. Our other solution here is 341.5 degrees. Those are our two solutions. That's giving us a little bit of a foundation to build on as we move into our next example. So on this next example, we're going to solve for x, and we're going to answer this in radians. So the first thing I'm going to do is I'm going to solve for our trig function. We got this sine x right here, and I'm going to isolate it. So I'm going to start by adding 7 to both sides. And then I'm going to divide by -4 on both sides. And so what we have is we're looking for where is sine -1/4. And we know that sine on our circle is defined as the y-coordinate. So I'm looking for where is y -1/4. I've left off the unit circle template here because we know that there's nowhere on that unit circle where the y-coordinate is -1/4. What I'd like to do now is I'd like to think, first off, what's reasonable and what quadrants are we going to be if sine is negative? And hopefully you're saying, oh, sine is negative anywhere the y-coordinate's negative. That's going to be down here in these two quadrants. So since it's not a unit circle value, we're just going to punch that into our calculator. We also need to make sure our calculator is in radians, and I'm going to show you how to do that. But if I type in sine inverse of -1/4, that's going to spit out the x value or the angle of rotation. And whenever we do that, if I'm in radians, I get x equals -0.25. Now, what's hard for me to visualize here is where is -0.25 here? What we know is if it's a negative angle of rotation, that means it's starting in standard position and it's rotating in a clockwise manner. So we just need to know where is -0.25. And so what I would do in order to actually figure out what this angle is, what is this angle right here I'm showing in purple, is we know that this is 2 pi. And we're taking away 0.25. And if I punch that into the calculator, you should get 6.03. Because we know this is roughly 6.28. 2 times 3.14 is 6.28. And if we subtract our 0.25, this is going to give us our fourth quadrant solution to this. So there's one solution. That this angle right here in purple that I've illustrated in purple is 6.03 radians. Now what we have to do is we have to do the same thing for the third quadrant. We know that my third quadrant is going to have that same reference angle of 0.25. That's the reference angle, 0.25 radians. So now you're thinking, okay, how do I visualize this? I'm going to show this part in green and standard position angle that makes it to there. Well, we know that halfway around the unit circle is pi radians. So we're going to do pi plus 0.25 in this case. That's going to give us 3.39. So if this is pi plus 0.25, that's going to give us 3.39 radians. So one of our solutions is 6.03 radians, and the other solution is 3.39 radians. Let's do our last example. And in this one, we've got a quadratic. Now, the first thing I like to do is I like to make this look a little bit more like a quadratic. The tangent throws me off a little bit. So I like to say, let u equal tan x. And then we substitute. Then what we can do is we can factor. I'm going to factor this trinomial on the left side of my equation. That's going to factor pretty nicely. We're going to have u plus 4 times u minus 1. And then by my zero product property, and now what we've done here is we've solved for u. However, it doesn't really matter what u is. We are looking for tan x. So if I'm looking for tan x, we got to substitute it back in. Now let's start over here. Where is tan x equal to 1? I don't have my unit circle on this slide, but we know that tangent is defined as y divided by x. So where is y divided by x equal to 1? That's going to be right here at 45 degrees, which if you did tan inverse right there, that's what the calculator would spit out. But we know tangent's also positive down here in the third quadrant. So if I take 180 and add 45 degrees to it, you're going to get your other solution of 225 degrees. Now let's bounce over here because this is the part that I think is a little bit more complicated. And so what we do over here is if we're going to do our tan inverse of -4, that's going to give us -75.96 degrees. Okay, so we already got our two solutions over here, and we've got our reference angle over here. Our reference angle is going to be 75.96 degrees. However, if tangent's negative, we know we're limited to a couple of quadrants. We know tangent's negative down here in the fourth quadrant, and we know tangent's negative up here in this quadrant. So if I'm using that reference angle of 75.96 degrees, we're looking for this angle right here that I'm showing in purple. And then our other angle will be up here, shown in green. If this is 75.96 degrees, I'm going to find the coterminal angle to put this angle, to find the angle that's coterminal in between 0 and 360. So for that angle, I'm going to do -75.96 plus 360, and I'm going to get 284.04. And then to get my second quadrant angle, we're going to take 180 and we're going to subtract our 75.96. And if I do that, I get 104.04. We have a lot of solutions to this. We've got these two that I'm highlighting in purple. We got those from this equation right here. And then we got these two, and those were the easy ones because those are unit circle values. Hopefully by the time you're watching this video, you know how to find those. And those are our 3 examples. I don't know how to wrap this up. The end.